Okay, students, this is problems 8, 9, and 10 from our homework from practice 1.2.2, and we're writing inequalities. And these are just the last couple from our homework, and we didn't get to cover them in class, so I don't want to go over them here. Okay, for number 8, we have a soccer game, and it says we have to have at least 5 players on a team. So when I start this up, that's my constraint. So we have 5 players, and here's my team. And I look at it, you have to have at least 5 players. So I'm going to have more than 5 players, and you can have equal to 5 players. So now I have to come up with this expression. It says that we start with 17 players. Okay. Now there's two things in this equation that the writer purposely put in here to try to confuse you. And what we're trying to prove here is a lot of times students look at problems and they see a number and they think they have to incorporate it somehow into the equation. And it's not always the case. So I'm going to highlight them here. It says after an hour of playing, 3 players start leaving after every 5 minutes. For at least how long can the team keep playing? Well, we've already played for an hour, so that's like in the past. We don't need to even worry about that. And 3 players are leaving in intervals of 5 minutes. Don't think that we have to put 5 minutes into the problem. We're going to put that into the variable. So I'm going to call t as my variable, and I'm going to call t as every 5 minutes. So it says here we start with 17 players and we lose 3 players every interval of time, and every time is 5 minutes. So notice in my expression that I wrote here, I don't have the 1 hour, I don't have the 5 minutes. It's not relevant for the equation. Now from here I can ignore the context, and from here I can just solve the problem. And notice we have negatives involved. So if when I subtract 17, we have a negative 3t, and we have a negative 12 over here. Now we have to divide by that negative. Prime example of why we're taking the opposite. And notice we get 4 here. Okay. We divided by a negative, so we have to switch the sign. So this is saying we have our intervals have to be 4 intervals or less. And each interval is 5 minutes. So I'm going to say that we have no more than 20 minutes of time. And you can include 20 minutes, up to 20 minutes. So we want to contextualize our answer as well. So that's how you want to approach this. Great example of evaluating negatives, great examples of knowing what to use in the equation and what to ignore. Okay, let's look at example 9, or problem 9. Okay, it says that we have $15,000 to give away. They decide to give away $1,000 twice a day. So that's kind of a tricky wording part there, until we have $3,000 left. So here is your constraint. So I'm going to start with $3,000. So that is what we have to have left for the grand prize. What you control is the contest. So I'm going to put my expression over here and label it the contest. The contest has to have at least 3,000. So you have to have more than 3,000, and you can include 3,000. Okay. Now we have, okay, what did we start with? And then how did it change? So those are the two terms that are involved. We started with 15,000 and we gave away money. Now, do we put 1,000 here? When I read this, it's asking for how many days did a price run. Well, if I'm doing $1,000 twice a day, am I really doing $2,000, per one day? So I'm going to use that as my coefficient. So I'm going to put 2,000 over here in the number of days. And I don't really care about how many times during the day, as long as how many days can I run. So once again, I'm going to undo my addition over here. Again, we are going to get negative values, and that is completely fine. So we have a negative 2,000 here and a negative 12,000 over here. We're going to divide to undo multiplication. And we have 6. Now I look at my work. Notice I did not write an inequality. I look at my work as a whole and say, did I divide and multiply by a negative? I did. So we're going to switch our sign. So what is the context of this answer? You have 6 days or less to make this contest work. Okay, so if the production manager of the radio show said, or the website said, hey, I want this to last a week, your math's going to show, well, I can do 6 days, I can't do 7. So you have to make sure that, whatever you come up with as a scenario for the contest works. And we kind of showed them math to prove that. Now, number 10 is a great example where here we're kind of asking you to like work backwards. We're going to give you a scenario as a mathematical inequality, and you have to give it context. Okay, so the first thing I'm going to do is make sure I understand the math. So I'm going to go ahead and solve for the inequality here. So to do that, I'm going to move this term to the other side. So we have 2x compared to 14. We're going to show division to undo multiplication, and we get 7. And notice, did I multiply or divide by a negative? I did not. So x has to be less than or equal to 7. Okay. Now the context I'm going to give is an actual problem that I came across in coaching one of my teams. We are having an away game, and we have to take 2 teams on a bus, and only one bus is going to come back early because the other bus has to stay late. So we had to figure out if we had enough room on the bus for the 2 teams. So this is how I'm going to read the scenario. So we have 2x minus 5 less than or equal to 9. I'm going to see 9 as my constraint. This is how much space is on the bus. This is seats on the bus. This coefficient is the number of teams. Okay. X, if I define the variable, is the number of players on each team. So I'm coaching soccer right now, so how big can each team be? And in 5, we have this extra constant here. This is the 5 players who go home. So we go to the game, play the game, their parents are at the game. These 5 players go home, which is good because it allows more room for the rest of the team. So this expression represents that. Oh, let me finish this off, going home. This expression represents that. So if I read this, it says, okay, we have 2 teams that played a game. 5 players are going to leave after the game with their parents, and we have to make sure that this all happens for a bus that only holds 9 people. Okay, so let's go ahead and look at the math, and let's now look at the answer and see how that answer fits in the context of the problem. So this says that each team can only have 7 players or less. Okay, now again, the reason why I have to do this mathematically is logically, just to be confusion. Right away you're thinking, well, that means 14 players total. How can that fit on a 9-person bus? Well, it can't. 5 players have to go home. Okay, so in this scenario, does this work for my team? Well, my team, we got 19 players on each team. That is clearly more than what the bus holds. So in this scenario, this bus would not work. I would have to change this number and get a bigger bus. So notice, in solving a problem, that's what inequality is. It's a range of answers. Am I in the right range or am I in the wrong range? Okay, so my conclusion is I would need a bigger bus because I can only have 7 players or less on my team.